Hello, hello. Hello, my dear friends. If anyone in the live, good evening, Praneeth. Good evening. Good evening. Good evening. Good evening, Dinesh. Good evening. My dear friends who are in the live, this is my sincere suggestion for you. Try to be in the live for the end. Okay. Okay. Try to be in the live till the end, because this class haloalkanes, haloarenes, very important lecture, that is SN1, SN2, SNI and the neighboring group participation E1, E2, E1CB. This application part is very important for our entire organic chemistry. So try to be in the class till the end, and if any doubts if you are having, okay, you will be there, okay, that is okay. For others I am saying, Pranit, you will be there. Then next, if you know the answer, try to give the answer, and you know, right? If you don't know, give me the question mark, so that we will save the time, and in the less time we can cover the more number of content, because SN1, SN2, SNI, SNNGP, E1, E2, E1CB, this many concepts we are there, and we have to cover the n number of questions also. Is it clear? Done. Now we'll start the class. Yes. Okay, 1 minute. 1 minute. Size. Sir, what about the duration of this? Duration of the stream max to max, I will try to finish it in the 1.5 hour to 2 hours, because this is very important, right? Max to max, I will try to finish in 1.5 hour to 1 hour 45 minutes, or if not, it will go to the 2 hours, because we have to cover n number of questions, and as well as it will be depend upon your questions answering, Nana. Dinesh, it will be depend upon your questions answering. Don't lag. Okay, my sincere suggestion for you is to don't lag. If you know the answer, try to say. If not, just give the question mark, so that it may not get lag. Right. Now in the SN1 reaction, what is the solvent we are going to use in the SN1 reaction? Just I will quickly recap the last class, so that it will be easy for us. Now this is a substitution unimolecular reaction, SN1. Now, good evening Abhinay, good evening. Okay, if you ask me, because this reaction every time it will make you confused, because alkali halide will give you the SN1 reaction, SN2 reaction, E1 reaction, E2 reaction. So that's the reason this class is very important. So let me finish this SN1 reaction. Now we know SN1 reaction. Now space prints. Now hi Prince, hi. Okay, Navin sir is getting love from Tamil Nadu also. Okay, fine. Space prints, try to be in the class till the end. If you are having any doubts, I will clarify you in the last. Okay, in the middle of the class, don't lag the class. Okay, if you are having any doubt, if you know the answer for that question, try to say. If not, give me the question mark. Hi Prince, hi. Done. Now I am going to start the class. Any concerns? Any concern? Anything you are having? Okay, done. Right. Now in the unimolecular substitution reaction, first we know 3-degree alkali halide, 3-degree alkali halide in the polar protic solvent, 3-degree alkali halide in polar protic solvent. What it will happen? The polar protic solvent H2O, aqueous medium, right? Aqueous KOH if I was taking. Now in the aqueous medium means this is polar protic. In this polar protic H2O, it will form the bond. Namaste asterisk. Namaste. Now due to the H2O, when it has formed the bonding with this halogen, now what it will happen? Due to that, no, you are at the correct time. You have attended the class correct time. Now what it will happen? Due to that what it will happen? Here the what? This H2O, due to this bond energy, what it will happen? This halogen, it will take this bond pair of electron itself and it will leave the what? It will leave the substrate and it will give you the carbocation, and we know carbocation is a sp2. Now when the carbocation sp2, it is a planar, we know it is a planar. If it is a planar, what it will happen? Nucleophile can be attacked from the above end and the nucleophile can be attacked from the below end. If the where the electrophile or leaving group it has been eliminated, at that side if the OH is added, then that product we say it as a retention. If it is attacked from the back end or reverse to the leaving group direction, if it is added, that we say it as a inversion. And this is a, and 50% retention and 50% inversion, we call it as a which one? Racemic mixture, that we know. Clear? Done. Then after that, what are the key points we have to remember? In this 3-degree alkali halides, alcohols readily undergo SN1. Then this is a non-concerted reaction. We know what is the meaning of the non-concerted. Non-concerted means intermediate will be present. Concerted means intermediate will not be present. Then carbocation is a intermediate that it will be present and rearrangement will be takes place. One thing, Nana, whenever the carbocation, intermediate carbocation, if it is formed, carbocation will be rearranged till it feels the stability. It will rearrange. It will search in the substrate. Still it feels the what? Stability. Clear? Done. Next. Very important point, that is in the SN1 reaction, it will not depend upon the whatever the nucleophile or incoming nucleophile we have taken. Only it will be depend upon the alkali halide which will provide the stable carbocation. If it is providing the alkali halide, if it is providing the stable carbocation, then that alkali halide will be depend upon it. Clear? Now here the potential energy and the reaction progress. Clear? You are going to see. First, formation of the stable carbocation is a slow process. Clear? I explained very clearly. If you take any mesh and if you take the sand, okay, if you take the sand, what it will happen? Clear? Now asterisk, what is the doubt you are having? What is the doubt you are having? You can ask. Clear? Now here if you take the sand, now what it will happen? Now that sand from that mesh, when it is come out from that mesh, it will be fall very fastly, right? Means the formation of the carbocation is okay. Done. Now the formation of the carbocation is slow step. Then after that, now the clear? Now next one we are having next we are going to see the which one? Professor, what is the doubt you are having? It will be depend upon the reaction, right? Professor, substitution reaction is which type of process? Thermodynamically and what? Chemical, kinetically it is also. What is your doubt? Substitution reaction is which type of process? Thermodynamically. Means I did not get you. Can you ask the question properly? Now, next. Next we are going to see. Now we have seen the graphs, rate of the reaction and the nucleophile. Done. Because the SN1 reaction will not depend upon the nucleophile. That's the reason it is substitution reaction is endothermic or exothermic. See here, when it comes to the substitution reaction, now substitution reaction is either the endothermic or exothermic. Here first, if you take the substitution reaction, first alkali halide I will explain. If you take the alkali halide, substitution reaction means one, this is the nucleophile. Done. Here when this halogen it has been eliminated, now this incoming nucleophile it is coming. When it comes to the SN1 reaction, one nucleophile it is going, another nucleophile it is coming. But for the SN1 reaction, what we have provided? We have provided the polar protic solvent. Now due to the polar protic solvent, H2O it is providing the bond energy. Due to that bond energy, it will take the what it will take? It will take the bond pair of electron towards itself. Now you have to say me, substitution is endo or exo. Now you have to say me whether how to decide the product. Here this H2O is providing the bond energy. Due to that bond energy, it is going from the substrate. Neither it will not give you the endothermic, neither it will not give you the exothermic. Substitution reaction, we cannot say whether it is a endo or whether it is a exo. Why we cannot say whether it is a endo or whether it is a exo? Because one substituent it is going, one sigma bond, one stable bond it is going and another stable bond it is forming. And how many reactants you have taken? The same thing, that many it will be at the product side. So there is no any change in entropy. There is no any, here the bond it has, sigma bond it has went with the halogen, the same sigma bond it has formed with one nucleophile. So we cannot say whether it is a endo or whether it is a exo. But I can say for the elimination reactions whether it is a endo or exo. For the elimination reaction, first sigma bond, strong sigma bond we have to break, right? We have to give the energy. So if you want to give the energy means easily we can say that is a endo. For the eliminations we can say, but the substitutions we cannot say whether it is a endo or exo. I hope it is clear for you. Done. Next, now the rate of the reaction will be depend upon the which one? Substrate. Clear? Done. Next we have seen the one ion pair mechanism. That what is the meaning of the ion pair mechanism? Ion pair mechanism means here when you have taken the alkali halide in the polar protic solvent, which one will be first it will form, they will ask. Which of the following product will be formed in the SN1 reaction, they will ask. First one, inversion product will form in the ion pair mechanism of the SN1. Why? Because here in the polar protic solvent, if when this halogen is leaving from the substrate, now whatever the nucleophile, if it is coming in that direction, we know halogen it is having the electrons and the nucleophile it is also having the electrons. What it will happen? Both it will be repelled to each other. That's the reason the first inversion product will form, then after the retention product will be formed in the which one? SN1 mechanism or SN1 reaction. This is also one very important, the statement based question they may ask. In the SN1 reaction, among the retention product, among the inversion product, which one will form first? So inversion product will be formed first. Clear? Done. Next. Now we have seen some questions. Now here in the given following, which one will readily show the SN1 reaction very fastly? Which one will readily show the SN1 reaction very fastly? Which one will show the SN1 reaction very fastly? Order you have to say me. Which one will readily show me, which one will readily show the SN1 reaction very fastly? Order you have to say me. Order you have to say me. Which one will readily show the SN1 reaction very fastly? Order. The one who are in the live, try to answer it. Which one will readily shows the SN1 reaction fastly among the 1, 2, 3, 4? 2, 4, 3, 1. Dinesh, 2, 4, 3, 1. Dinesh, why you have chosen the 1 as last? Dinesh, why you have chosen the 1 is last? Dinesh, once you cross check the molecules once again you cross check. Once again you cross check the molecules. Sir, it's not benzene. These are cyclo compounds. Then what is the answer? What is the answer? Now, any other? What is the answer? Can anyone? What is the answer? Should I say? Okay, done. Now you see. Now here the what SN1 reaction will be depend upon the alkali halide which will provide the stable carbocation. See, if these carbocations, if these halogens are eliminated and if the carbocation, if it has formed here, now you cross check. Which among the following is a more stable carbocation? Which among the following is a more stable 2, 1, 3, 4. No, Mridul, partially you are correct. 50% you are correct. Mridul, 50% you are correct. Partially you are correct, not completely. See, here this oxygen due to the plus M effect, it will stabilize this carbocation very fastly. So it is providing in the SN1 reaction, 2 will react very fastly. But next when it comes to here the 0 alpha hydrogens we are having. Even though it is having the 0 alpha hydrogens, but plus I effect of the methyl groups are there, right? Plus I effects of the 4 methyl groups, it is stabilizing. So methyl groups are stabilizing. So 1. Then here it is when this oxygen's plus M effect will not be work because these carbons are sp3 and the carbocation. Now it will be act as a minus I. It will act as a which one? Minus I. Now due to the minus I, now minus I is nearer to the carbocation. Now here the minus I is far away from the carbocation. Yes, 2, 1, 4, 3. Now in this manner the rate of the SN1 reaction will be happen very fastly. So the order will be 2, 1, 4, 3. Order will be 2, 1, 4, 3. Is it clear? Is it clear for everyone? Is it clear for everyone? Is it clear for everyone? Now. Yes sir, done. Now next one I will write. Now you have to say me in which case SN1 reaction will be happen very fastly. SN1 reaction will be happen very fastly, you have to say me. Among the 1, 2, 3, in which case SN1 reaction will happen very fastly. in which case SN1 reaction will be happen very fastly. SN1 reaction 3 to 1. Good. 3 greater than 2 greater than 1. Why? Because if these halogens are eliminated, if these halogens are leave from the substrate, here the 1, here the plus, here the plus. Clear? Here only the plus m of the benzene. Now here of the plus m of the benzene, here the plus m of the benzene. Plus m of the benzene is common here up to here, but here we are having the 3 alpha hydrogens, but here we are having the 6 alpha hydrogens. Plus m plus 6 alpha hydrogens in the third case. Plus I plus, not plus I, plus H. This will provide the plus H to the sp2 carbocation. Okay? Plus H, 6 alpha hydrogens. So the order will be 3 to 1. Done? Okay, right. Okay, right. Now the next another type of the reaction that we are going to study, that is SN2 reaction. Next reaction we are going to see, that is a which one? SN2 reaction. In the SN2 reaction, now what is the SN2 reaction? Now SN2 SN2 reaction. In this SN2 reaction, first of all, many of the students, they will get confused in identification of the, sir, it won't show plus. I mean, actually alkali will show both plus H and plus I, but among those two, for the carbocation which is dominating means plus H will be more dominating. Alkali will show both plus H and the plus I, both it will show, but among those two which is more dominating, if they ask, plus H will be more dominating for the carbocation. Both it will show plus H, this methyl groups, plus H and the plus I, both it will show. Is it clear, Dinesh? But plus H is more dominating. Okay, done. Next, in the SN2 reaction to show, first one is a polar aprotic solvent is a favorable. Which one? Polar aprotic solvent is favorable. In this polar aprotic solvent, first of all, the first polar aprotic solvent, one we are having, that is ether. Ether is a polar aprotic solvent. Next, DMSO. This is the structure of the DMSO, so that you will have some idea of the solvents also. Sometimes they will give you the solvent. Actually, in the organic, they can make you confused with anything. Many of the students, what the examiner, how they will confirm, they will confuse you, you know, with the, sometimes they will give you the solvent structure. Instead of giving the DMSO, they will give you the solvent structure and they will make you confused. And you will think something they have given. So remembering of the solvent structure is also very, very important. So this is dimethyl sulfoxide. Clear? Next one we are having the DMF. Dimethyl formamide. This is a dimethyl formamide, DMF. Okay. Next, acetone is also one type of the polar aprotic solvent. Done. Next one, dimethyl acetamide. Dimethyl acetamide is also one type of the example for the polar aprotic solvent. Dimethyl acetamide. Clear? Next, hexamethylene phosphoramide. Hexamethylene phosphoramide. This is a hexamethylene phosphoramide. Okay. Sometimes they will give you the solvent structure and they will ask you to make you confused. So these are the some polar aprotic solvents we are going to use. Now we'll see the reaction. Now 1 degree alkali halide, 1 degree alkali halide. Clear? 1 degree alkali halide upon polar aprotic solvent. upon polar aprotic solvent, what it will happen here, the first the transition state it will form, one transition state it will form. What is the meaning of the transition state? Now here the bond is breaking, now here the bond is forming, from this nucleophile the bond is forming. Clear? Now this cycle, then one transition state it will form, then after that we will get the one inversion product, in this manner. Done. Now why the inversion product we are getting here? Because we know already, I explained you very clearly, polar protic solvent, in the polar protic solvent cation and anion both are soluble, but in the polar aprotic solvent, only cation is soluble but not anion, I explained very clearly for you. Then if the alkali halide, now the DMSO I was taken, now DMSO will not soluble this anion. Clear? DMSO is not having the chance to soluble this anion. So when this anion is not getting soluble by the solvent of DMSO, then this halogen will not leave from the, or halogen will not get the, no, halogens will not get the sufficient bond energy to leave from the substrate. So that's the reason what it will happen, whatever the nucleophile we have taken, if you take this as a strong nucleophile, what it will happen, this strong nucleophile which should go and attack from the back end. It should go and attack from the back end. Then when this nucleophile is going and attack from the back end, if this carbon is free from the steric crowd, then this nucleophile will go and attack very fastly. Let's suppose if you take the 3-degree alkali halide, in this manner, for this 3-degree alkali halide, whatever the nucleophile you have taken, these are, when this DMSO, it is not having chance to dissolve this halogen, then this nucleophile, it should be attacked from the back end. If it is coming from this end, what happened, this methyl groups, these bulky groups will repel this incoming nucleophile. Due to that what happens, its attacking strength will be decreased for the 3-degree alkali halide. That's the reason 3-degree alkali halides will not react with the SN2 reaction. Why? Because due to this steric crowd, it will not allow incoming nucleophile to attack from the back end. Done. So if you take the 1-degree alkali halide, 1-degree alkali halide is free from the steric crowd. Very fastly the nucleophile it will go and it will give you the inversion product. You can see here, here the bond is forming, here the bond is breaking, here the nucleophile it is going from the back end, sorry, here the leaving group is leaving, and from the back end what nucleophile is adding. So due to that what we got the inversion product. Is it clear up to now? Done. Now here we'll see the rate of the reaction for the SN2. Rate of the reaction for the SN2 will be depend upon the whatever the substrate you have taken and incoming nucleophile. How much strong nucleophile you have taken, that much fast SN2 reaction will be happen. So here the order with respect to the substrate is 1 and the order with respect to the incoming nucleophile is 1. So the order of the reaction is 2. That's the reason we used to say bimolecular substitution reaction. Now we have seen there is no any intermediate formed in the reaction. Then if you see the graph and the reaction progress and the potential energy and the reaction progress, if you take, now this is the one reactant alkali halide. Now this is a concerted reaction. What is the meaning of the concerted? There is no any intermediate it is formed. Then here we'll see the some graphs, rate of the reaction and substrate. How the graph you will get, Anna? Now the rate of the reaction versus substrate, how the graph you will get? how the graph you will get. Rate of the reaction and the substrate, how the graph you will get. Among the rate of the reaction and the substrate, how the graph you will get. Y is equal to mx. Good. Y is equal to mx. So straight line passing through straight line. Good. Next, for the rate of the reaction and the nucleophile. Now rate of the reaction and the nucleophile. 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 Okay. Now here this is also y is equal to mx. Clear? This is a y is equal to mx. Done? Clear? Now next we will go. Done? Next one. Let some haters will come. Let them see. Okay. Now leave Nana. See, my intention is to give the free content for the one who is serious for the education for their respective following exams, either for the JEE and the NEET. Okay, sometimes some may like, some may not. Okay, it is up to them. Let it be. Clear na? Now the SN1 and the SN2 has been cleared. Now we'll see the some type of the reactions. Which one will give you the SN1 reaction and which one will give you the SN2 reaction very fastly. Now we have to see. Okay. Now here among the one and among the two, which one will give the SN1 reaction very fastly? Among the 1 and 2, which one will give you the SN1 reaction very fastly? Wait. Not this one. Wait. Okay, I will take a OH. Not OH. I will take here I will take better. Okay, phenol. Okay, right. CH3 will. Okay, CH3 will take. Done. Now among the 1 and 2, which one will give you the SN1 reaction? You are saying it as 1. You are saying it as a 1. My dear friends, is it the final answers for you? For everyone, is it the final answers for you? Is it the final answers for you? Is it the final answer? Steric crowd. What the steric crowd? What is the steric crowd? Lone pair does not donate. Here there is no SN1 reaction as well as SN2 reaction. Here there is no SN1 as well as the SN2 reaction will be happen. May I know the reason? Why the no SN1? Why the no SN1 as well as SN2? May I know the reason why the SN1 and the SN2 will not happen? Why the SN1 and the SN2 will not be happen? May I know the reason? This is a very important application part of the question. So, vinyl carbocation. You may think that whenever they have given this one, so many of the students they will get confused here. you will think that this is a methoxy. Here if this halogen, if it is eliminated, here the carbocation will be formed. So this carbocation, due to the plus M effect, it will stabilize this carbocation very fastly. Many of the students, they will think and they will pick this option and they will come, but this option will become wrong. Why? Because here in the benzene, we know, right, benzene each carbon hybridization is sp2. Benzene each carbon hybridization is a sp2. In the benzene each carbon hybridization is a sp2. Then in the sp2, what, how many orbitals will be intermixed? Only 3 orbitals will be intermixed, and the another one will be the, which one? Another one will be the pure p orbital, and this pure p orbital is perpendicular to the hybridized orbitals. I explained very clearly. Then here it is a hydrogen, now here it is a hydrogen, now here it is a hydrogen, now here it is a hydrogen, and here it is a hydrogen. Now here it will be the OCH3. Done. Now here how the pi bond will be formed? Now the pi bond will be formed in this manner. Now this is a one pi bond. Clear? Now here the one pi bond. Now here the one pi bond. Clear? Done. Here this, in this manner the pi bond will be formed. Now when this pi bond it has formed in this manner, now it will delocalize, right? Completely it will be delocalized. It will be delocalized. This pi bond will be delocalized. See, if this carbocation, if it has formed here, if any bromine it has eliminated, and if the carbocation, let's suppose it has formed here. Done. Here the carbocation it has formed. The carbocation which is formed, you can see this carbocation will be in this manner, this orbital. This positive charge will be the perpendicular to the, which one? Perpendicular to this, which one? To the pi bond, right? Okay, let me try to show me, wait, let me try to show me the benzene in the live class. Be in a line. I will show you so that it will be clear for you. I hope the benzene is clear. Is it appearing for everyone? Is it appearing? Is this benzene is appearing for everyone? If it is appearing, try to say me yes, so that I will clear for you. Is it benzene is clear? Yes sir, done. Right. Now you see me. Here this is a benzene, right? Now in this benzene, this is a pi bond. Okay, done. Now you can see this is a pi bond of the benzene. Now this is a pi bond of the benzene. Now this is a pi bond of the benzene. Clear? Now the mesomeric effect is happening. Let's suppose this is a aniline, NH2 and its nitrogen lone pair. These two are parallel to each other. You can see. Now this lone pair of electron and this pi bond is parallel to each other. That's the reason mesomeric effect is happening on the benzene. Now here, if this halogen, if it is eliminated, if this, let's suppose this is a leaving group. Now this leaving group has been eliminated. If this leaving group has been eliminated, now here one orbital it should get, right? Here one vacant orbital it should get, right? Now you can see. If you see, now this pi bond and this vacant p orbital, this positive charge, whatever we are having here, this positive charge and this pi bond is parallel to each other or perpendicular to each other. Now you try to say me. This positive charge and this pi bond, benzene pi bond, are parallel to each other or perpendicular to each other? Perpendicular to each other. Good. Then here, whatever this nitrogen lone pair of electron it is there, already this is parallel to each other, right? already this pi bond and this oxygen lone pair of electron, already it is which one? Parallel to each other. Then already this pi bond, benzene pi bond is perpendicular to this one, means obviously this lone pair of electron, also will be perpendicular to this one. Then why this lone pair of electron will stabilize this carbocation? There is no any plus M effect. There is no any plus M effect. For this carbocation, here the plus M effect will not be happen. If the plus M effect is not happening, then oxygen being the minus I, what it will do? It will pull this sigma bond pair of electron towards itself. When it is pulling this sigma bond pair of electron towards itself in the form of minus I, what happens? Its stability will be decreased. Its stability will be decreased. That's the reason SN1 will not happen. But when it comes to the SN2 case, now in the SN2 case, if you cross check, now you see, in SN2 case, if you cross check, here this is a leaving group, okay, this is a leaving group. Now this leaving group, in this manner you can cross check. This leaving group, now one incoming nucleophile, let's suppose this is a one incoming nucleophile, this is a benzene, okay, this is one incoming nucleophile. This incoming nucleophile, from the front end it cannot come. From the front end it cannot be attacked, because this lone pair of electron, will be repelled. Then it should be attacked from the back end. If it is want to be attacked from the back end in this manner, now this pi electrons, what it will do? This pi electrons, it will keep on delocalized, right? These pi electrons keep on delocalizing. If these pi electrons are keep on delocalizing, now if this incoming nucleophile, if it is coming here, what it will do? It will repel this incoming nucleophile. When it is repelling this incoming nucleophile, there is no chance of attacking nucleophile to this benzene. When there is no chance of attacking to this benzene, how the SN2 reaction will be happen? So halogen directly attached to the benzene, there is no SN1 and there is no SN2 reaction. Is it clear for everyone? Is it clear? This is very important. Examiner, they can stress and they can make you confused. Many of the students, they are getting confused here. I hope it is clear for you. Any halogen attached to the benzene, there is no SN1 and there is no SN2. Clear? You have to be very careful. Very careful you have to be, because many of the students in the hurry bari, they will pick up the answer, the first one, and they will feel that that is the correct, but it is actually it is wrong. So you have to be very careful with this one. Why it will not be happen? Done? Right. Right. Now, clear, there is no any SN1 and there is no any SN2. Clear, if any benzene substituted, you can see, if any benzene substituted, if the benzene, if it is having the positive charge and if it is any plus M groups are attached, or plus M and the minus M groups are attached, okay, now you say me, among this following, in this following, if this carbocation, if they have given, if I was given the carbocation here, among the 1 and 2, which is more stable carbocation? Among the 1 and 2, which is more stable carbocation? Among the 1 and 2, which is more stable carbocation? Among the 1 and 2, which is more stable carbocation? Among the 1 and 2, which is more stable? Arey Praneeth, among the 1 and 2, which is more stable carbocation? It is 2, not 1. Here plus M and the minus I. Plus M and the minus I. In the plus M and the minus I, when the vinyl carbocation, if it is present, plus M, this positive, this vacant p orbital and this oxygen lone pair of electron, both are perpendicular to each other. When they are perpendicular to each other, there is no any plus M effect will be happened. Only the minus I effect will be dominating for this one. So minus I groups will be destabilize the carbocation, right? Now here what it will happen? Here this is a plus H and plus I. But here the plus H effect of the methyl group is not present, but plus I is present, right? Plus I will stabilize this carbocation. This is very, very important molecule. You have to be very careful with this type of the molecule they have given. Done? Now, right. Now I will write some substrates. Okay. Which one will give you the SN1 reaction very fastly? Which one will give you the SN2 reaction very fastly? You have to same. Done? Here, SN1 reaction, if suppose 3 degree alkali halides they have given, SN1 will give very fastly, we know. 3 degree alkali halide. 3 degree alkali halide if they have given, SN1, SN2. SN1 will give you very fastly because it will provide the stable carbocation. SN2 will not give because steric crowd. Now 2 degree alkali halides if they have given, 2 degree alkali halides if they have given, and 1 degree alkali halides if they have given. 1 degree alkali halides if they have given, SN1 will not react but SN2 will react. Why? SN1 due to the less stable carbocation it will not react. With the less steric crowd, incoming nucleophile will go and attack and it will. But when the very difficulty the many students they will face in the deciding of the 2 degree alkali halide. In the 2 degree alkali halide it will react with the both it will react. SN1 it will react and the SN2 it will react in the 2 degree. But how to decide? How to decide whether the SN1 is dominating or SN2 is dominating? So there you have to be very careful. If weak nucleophile if they have given, weak nucleophile, what are the weak nucleophiles? H2O, then alcohol, next phenol, next ammonia. Clear? If suppose if they have given weak nucleophile if they have given, SN1 will be favor. Strong nucleophiles if they have given, what are the strong nucleophiles? Strong nucleophiles if they have given, I minus, clear, Br minus, Cl minus, clear, Cn minus, clear. Now PPH3 triphenyl phosphine, now SH minus, clear, done, OH minus. If suppose if they have given strong nucleophiles if they have given, strong nucleophiles if they have given, readily it will undergo the SN2 reaction. Is it clear? Is it clear, right? Is it clear? Now next we'll see the which one? Okay, right. Now allyl halide, sir, is it not NH3 categorized under the strong nucleophile or I am wrong? No. NH3 is a weak base. Ammonia is a weak base. Ammonia, if it is a weak base, ammonia it is a weak base. Ammonia it is not the strong base. No, it is not the strong nucleophile. Because strong nucleophile means if the ammonia, if it is, wait, I will explain why the ammonia will comes under the, it is not comes under the strong nucleophile means, here this lone pair of electrons of the ammonia if it is given, it is not stabilizing by the H. Then if it is not getting stabilized by the H, it will not provide the lone pair of electrons very fastly. This NH3 is not strong nucleophile. NH2 minus will be the, in comparison with this NH3 and NH2, NH2 minus is a strong nucleophile. Not neutral NH3 is not strong nucleophile. NH2 minus is a strong nucleophile compared to the NH3. Is it clear? Done. Okay, fine. Now, right. Yes, sir. Done. Right. Now, triallyl halide. Triallyl halide. If suppose triallyl halide, if they have given, now it will, which reactions it will undergo? Very fastly. Fast ga cheppandama. Try to say me fastly. Try to say me fastly. Try to say me fastly. Which reactions it will undergo? Now, SN1 pakka. What happened to the SN2? What happened to the SN2? SN2 also it will undergo. SN2 also it will undergo. SN2 depending upon the nucleophile. Depending upon the nucleophile, but SN2 also it will readily undergo. In this one, it can attack. Okay. Now, in this one, now para electron withdrawing group containing benzyl halide. 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 Para electron withdrawing group containing benzyl halide will undergo which reaction? Will undergo which reaction? Unstable carbocation. I am asking whether it will undergo SN1 or it not. Whether it will undergo SN2 or not. Or both it will undergo or both it will not undergo. Both it will undergo or both it will not undergo. No SN1. Okay, good. Then SN2? SN2? SN2 it will be happen very fastly. Sir, how to decide the SN2 means? You see, here, listen carefully here. Here, now how the SN2 will be happen? What are the main condition to the SN2 happen? This is halide. Now, here the electron withdrawing group is there. Now, electron withdrawing group, what it will do? It will weak the, what it will do? The strength of this alkali halide and this carbon group will be weak. ఈ కార్బన్ కి ఈ హాలోజన్ కి ఉన్న బాండ్ స్ట్రెంగ్త్ ని వీక్ చేస్తుంది. ఏది? ఎలక్ట్రాన్ విత్డ్రాయింగ్ గ్రూప్. వెన్ ఇట్ ఈస్ మేకింగ్ ఇట్ యాజ్ అ వీక్, then the nucleophile can attack very fastly and this halogen will be leave from the substrate. Then the rate of the SN2 reaction will be happen very fastly. ఇక్కడ ఈ ఎలక్ట్రాన్ విత్డ్రాయింగ్ గ్రూప్ ఉండడం వల్ల ఈ కార్బన్ కి హాలోజన్ కి ఉన్న బాండ్ స్ట్రెంగ్త్ ఏదైతే ఉందో వీక్ అయిపోతుంది. బాండ్ స్ట్రెంగ్త్ వీక్ అయిపోయిందంటే ఇక్కడ నువ్వు స్ట్రాంగ్ న్యూక్లియోఫైల్ అయినా తీసుకో, వీక్ న్యూక్లియోఫైల్ అయినా తీసుకో, వెరీ ఫాస్ట్లీ ఇక్కడ అటు కాగానే ఇదేమవుతుంది? హాలోజన్ ఇట్ విల్ టేక్ ఇట్స్ బాండ్ పేర్ ఆఫ్ ఎలక్ట్రాన్ అండ్ ఇట్ విల్ లీవ్. సో SN2 రియాక్షన్ విల్ బి హ్యాపెన్ వెరీ ఫాస్ట్లీ. Is it clear? SN2 reaction it will be happen. Done. Next, very important reaction, very important one reagent I will write, and they are asking whether the SN1 reaction will be happen or not. Then you have to decide. Here many of the students they are getting confusion with this with this reagent, sir, with this substrate. If suppose this substrate if they have given, suppose if this substrate if they have given, whether it will undergo SN1 or SN2 or both it will undergo or both it will not undergo. This is a one very important substrate. They are repeatedly they are stressing with the SN1 and SN2. This is the application part. This application part is very very important. Now here itself you will get to know, by this substrate itself I will get to know that you have understand the SN1 or SN, you have not understand the SN1 or SN2. With this substrate, with the given substrate, which one it will readily undergo? SN1 or SN2 or both, or it will not undergo both? Now, if you know the answer, try to say me. If not, give me the question mark. I will explain. This is a very important substrate for the SN1 and the SN2. What it will undergo? It will undergo both or both, sir. How you are saying, Pranit? How you are saying the both it will undergo? How you are undergoing? How you are saying this both, sir? Because if this halogen, if it is eliminated, if the halogen, if it is eliminated, it will generate only the 1 degree carbocation, right? Sir, carbocation. I am asking how you are saying the SN1. Because it is providing only 1 degree carbocation. How you are saying that it will give you the SN1? 1 degree with the 1 degree carbocation, SN1 reaction will not undergo it. Good. Due to the plus M effect of this oxygen, this carbocation is stable. So the one which provide the stable carbocation, SN1 reaction will happen very fastly. And due to the less steric crowd, for the SN2 reaction will be happen very fastly. Due to the less steric crowd, now SN2 reaction will be happen very fastly, and the one which it is providing the stable carbocation, now it will give you the SN1 as well as the SN2. Both it will give. Okay. Now next you say me this one. The same reagent. Now with the same reagent, now you see me, which one will give you the SN1 and which one will give you the SN2? Or both it will give or both it will not give? Which one will give you the SN1 and which one will give you the SN2? Both it will give you the SN1 or both it will not give you the SN2? Now how to decide here? How to decide here? Which one will give you the SN1, which one will not give you the SN1, both will give you the SN1 or both will not give you the SN1? How to decide here? This is very, very important. Don't know, right? Listen, here the SN1 will not be happen, SN2 will be happen. Why? Because here if the stable carbocation, if it is formed, here the stable carbocation, 1 degree carbocation it is formed, but here the directly by the elimination of the halogens, carbocation is providing, carbocation is forming, and directly plus M of this oxygen is stabilizing. But you may think that, sir, carbocation, you have said that carbocation rearrangement will be happen, but in which case it will be happen? If it is provided the stable carbocation, but here itself it is providing the 1 degree carbocation as a unstable. That's the reason here the plus M effect of this oxygen will not be stabilize this carbocation. Now it will be act as a minus I. Minus I will be more dominating for this oxygen than the plus M. So that's the reason SN1 will not be happen. But incoming nucleophile for the SN2 it is free. Then the halogens it will be eliminated. Then it will give you the SN2. Is it clear? Is it clear for you? Is it clear? These two molecules are, these two substrates are very, very important for the SN1 and the SN2. See, alkali halide attached carbon, if it is attached to the oxygen, both SN1 and SN2. If it is attached to the two other carbons, there is no any SN1, only SN2. This is very, very important. Examiner is repeatedly stressing this type of the molecules. Okay, done, clear, right, fine. Now what are the substrates that it will be involved in the SN1 and what are the substrates that it will not be involved in the SN2? We got to know. And vinyl halides, now benzyl halides and bridged carbon containing halides will not give you the SN1 and SN2, that we know. Clear? Right. Next, one conversion I will write. Then you have to see me. Here it is a OH, Now, clear? And they will give you the one tosyl chloride. It is A. Then tosyl chloride upon A, and after NaCN, it will give B. It will give B. What is the IUPAC name of B? What is the IUPAC name of the B? Now, if you know, try to say me the answer. If not, give the question mark. If you know the answer, try to say me. If not, give me the question mark. I will explain. OTS, good living group. Yes. Yes, OTS is a good living group. Okay, lol, good. Nana lol, what is your name? Lol factory. But saying the lol is, it is somewhat difficulty for me. Lol, what is the name for you? What is the name? What is your name? May I know your name? So that I can call you with your name instead of saying lol. Lol or factory. Propane 2 nitrile. Ansh. Okay, Ansh. Propane 2 nitrile. 2 cyanopropane, sir. Propane 2 nitrile. IUPAC is wrong. Pranit, whatever the IUPAC you said, it is wrong. IUPAC, whatever you have said, product is correct. Whatever you are thinking, the product is correct. But IUPAC is wrong. Product correct. నీకు వచ్చిన product correct. కానీ దానికి నువ్వు చెప్పిన IUPAC రాంగ్. ఆర్డర్ కాదు, నువ్వు రాంగ్ చెప్పినావు. You have said wrong. Listen. Here, first one, this is a tosyl chloride, right? This is a tosyl chloride. Now, tosyl chloride. Now, we can represent the tosyl chloride in this manner also. Okay? 2-methyl propane nitrile. Ah, good. 2-methyl propane nitrile. Darshan, good. Good. That is 2-methyl propane nitrile. Now, whenever the cyanide they have given, cyanide carbon also will be considered as a parent carbon chain. 2-methyl propane nitrile. Whenever the cyanide they have given, its parent carbon chain. Consider the cyanide carbon as a parent carbon. Already I explained very clearly. Any carbon containing functional groups, if they have given, that carbon should be the high priority. That carbon should be the first priority and it should be considered in the parent carbon chain. So that's the reason I asked you the IUPAC name. Many of the students, already I explained you very clearly. You know the content. Why you will feel the chemistry difficulty for the many of the students, I explained you very clearly. Why? You know the content. You know the reagent, what it will do. But examiner, they will stress with the IUPAC. Sometimes they will give the IUPAC. You know the concept. But if you don't know the IUPAC, what is the use of it? So, my dear friends, IUPAC will play very, very crucial role. That is the first key step. That is the first key step to the success in chemistry. Organic chemistry, the first key step is strengthen in the IUPAC. Later you may get content, everything, concept, content, everything you will get easily. But you know, entire product you know. But if suppose if we ask the IUPAC in the question, what you will do? You will, that option also will be there. Which one? 2-methyl propane nitrile will be there. Propane 2-cyanopropane also will be there in the option. So listen. Okay. Now this is a tosyl chloride. Now tosyl chloride as a HCl it will be eliminated. As a HCl it will be eliminated. As a HCl it is eliminated. then what it will get? Now it will be converted into the OTS. Now this entire group is a OTS. Now the OTS is a good leaving group. Clear? Now the OTS is a good leaving group. Now when the OTS has been good leaving group, it has been eliminated. But here you have to say me which reaction has been happened here, SN1 or SN2, because it is a OTS is a good leaving group. If the OTS is a good leaving group, now which reaction is happening here, SN1 or SN2, because this is a 2 degree carbon. 2 degree one leaving group is present at the 2 degree carbon. Now you have to say me it is SN1 reaction or SN2 reaction, whether the SN1 has happened or SN2 has happened, which reaction or which reaction mechanism it has followed, SN1 or SN2. SN1 follow aయిందా, SN2 follow aయిందా? SN1 it has followed or SN2 it has followed? Fastly. SN1 reaction it has followed or SN2 reaction it has followed? No, SN2, because this is a cyanide is a strong nucleophile. Both can happen, కానీ ఇది strong nucleophile కదా. Cyanide is a strong nucleophile, right? So being the cyanide strong nucleophile mechanism, it has followed SN2. Mechanism it has followed SN2. Clear? Cyanide being the strong nucleophile mechanism, it has followed the SN2. Now we'll get the yes, okay, Ansh, no problem, Nana, Ansh, no problem. Okay, so you have to be this type of the mistakes only we have to rectify itself. Okay, cyanide being the strong nucleophile, already explained, with the strong nucleophile SN2, with the weak nucleophile SN1. With the only SN2 will make us confused. That's it. Nothing they will make. Next one high level of the question, not high level, normal level only, but it is new to you. It is new to you, and the examiner also they will make you confused with this type of the molecule, so that in the without getting confusion in the exam, here itself I will make you. Now ethyl alcohol I was taking, ethyl alcohol. Okay, ethyl alcohol in the presence of trimethyl silyl chloride. Trimethyl silyl chloride. Done. Trimethyl silyl chloride. After the trimethyl silyl chloride, done. Now here it will give you the which one? Here it will give trimethyl silyl chloride. If they have given it gives A. It gives A upon NaBr. NaBr gives B. B has followed, this one has followed which mechanism? This has followed which mechanism? This is step 2 followed which mechanism? Step 2 followed which mechanism? SN1 or SN2? Clear? Now ethyl alcohol upon trimethyl silyl chloride gives A upon NaBr, it will give SN2. SN2 you are saying. How you are saying it is SN2? How you are saying it is SN2? Pranit, how you are saying SN2? How you are saying it is SN2? Br minus. Sir, Br minus is a strong nucleophile, you have said. So it is SN2. Okay. Then can you say me the product of A? Can you say me the product of A? It is 3 degree. What 3 degree? No 3 degree. No. Now how the product will be? Remember, this is very important one. It will make you somewhat confused. Whenever the trimethyl silyl chloride, if they have given, this is CH3, this is CH2. Now this is the oxygen, right? And it is a H. Okay. Now the trimethyl silyl is having the vacant orbital. We know silicon it is having the vacant orbital, and it is a chlorine. And we are having the which one? Here the 3 methyl groups. Then as the HCl it will be eliminated. As the HCl it will be eliminated. Now this oxygen lone pair of electron will be accepted by the chlorine to this vacant orbital and it will form in this manner. How? CH3, CH2, O, Si, Me, trimethyl. Clear? Now this Br minus from the back end which is having the nucleophile, it will go and attack to this carbon, and O it will take this, which one? O it will take this bond pair of electron and it will leave, and it will give you the SN2 mechanism, and it will give the SN2 mechanism. Is it clear? Is it clear? Now this is a product A. This is a product A. Is it clear? No, right. No, next. Right. Next, should I write the okay? Should I write the IUPAC or should I give the with compound? Okay, I will give you the compound only. Better. Next one I will stress with the IUPAC. First I will give with this compound. Next I will stress with the IUPAC. Okay. Now here, first I will stress with the this one only. That's what I am saying. First I will give with the compound. Second one I will stress with IUPAC. Okay. Second one I will stress with IUPAC. Here the Cl. Okay. Now, what are the products? This OH minus, SN1, when this substrate, when it has followed the SN2, OH minus. When it has followed the SN1, what are the products we will get? What are the products we will get? And when it has followed the SN2, what is the product we will get? Okay, I will explain for this one. And the second one you try it from your end. Okay. Here, listen. Whenever this type of the questions they have given, now this compound IUPAC name is cis. Will you try this IUPAC name? Will you try the IUPAC name of this compound? Will you try the IUPAC name of this compound? Can anyone say the IUPAC name of this compound? Try it the IUPAC name of this one. So in SN2 remove Cl and add OH and invert it. SN2 remove Cl, add OH means OH will be comes in dotted line or wedge line. Cis 1 chloro 4 methyl, cis 1 chloro 4 methyl cyclohexane. Good Nana. Right, good. Cis, this is cis because 1, 2, 3 and this is 4. Okay. Then if the wedge rotations are, if the hydrogen similar groups are at the dotted notation, that we call it as a cis. And here in the SN2 the products will be, SN1 the products will be in this manner. Here the hydrogen, here the Me, here the Me. Now here the OH, now here the H. Okay. Next one, here the H, here the Me, now here the dotted OH, now here it is a wedge H. Now this one is a trans, and this one is a cis. Now these products are from the SN1. clove. For the SN2 the same product. For the SN2 this product only will get. This product only will get for the SN2. Now for the SN2 you will get this product only, right? SN1 and the SN2 same. Next question, last question I will stress and I will stop the SN1 SN2 session. Now we'll go with the elimination now. Last question I will stress for this one. Now you have to say me which mechanism it has followed and what is the IUPAC name of the product. What is the IUPAC name of the product and which mechanism it has followed? What is the IUPAC name of the product and which mechanism it has followed? What is the IUPAC name of the product? Which mechanism it has followed? For this one, what is the IUPAC name of the IUPAC name of the compound and which mechanism it has followed? What is the IUPAC name of the compound and which mechanism it has followed? Now which mechanism it has followed? Now what is the IUPAC name of this one and which mechanism it has followed? SN2. How come Pranit, how come it is the SN2? Ansit, SN2 SN1 एक बार explain करो ना please. SN1 SN2 SN1 3 degree alkyl SN1 3 degree alkali halide in the presence of polar protic solvent. It will do? It will readily undergo. Now 1 degree alkali halide with the polar aprotic solvent, it will readily undergoes SN2. That's it. Simple. Here this aqueous AgNO3 if they have given, now here it will form the Ag plus. Now in the reactivity series, ring expansion, in the reactivity series Ag plus ion, how the AgNO3 will be dissociate? AgNO3 will be dissociated into the Ag plus and NO3 minus, right? Now in the reactivity series OH minus nucleophile in aqueous solution. Good. In the aqueous solution from the OH minus. Good. OH minus is the nucleophile in the aqueous solution. Good. And Ag plus is the very high reactive in the reactivity series. Now in the reactivity series Ag plus is the high reactive. Then what it will happen? Now this Br with the Ag it will be eliminated. As the AgBr it will be eliminated. Then when the AgBr it has been eliminated, now ring adjacent carbon if it is having the positive charge, ring expansion will be happen, right? Ring expansion will be happen. Then ring expansion how it will be happen? 1 carbon, 2 carbon, 3, 4, 5, 6. Now this carbon will be given to this carbon. Now 2 will get the positive charge and the ring expansion will be happen. Now how the ring expansion? 1, 2, 3, 4, 5, 6. Now when the ring expansion happen, now the 2 number carbon will get the positive charge and from the aqueous solution nucleophile will be there, OH will go and attack. Then it will get the cyclohexanol or cyclohexane 1-ol. Cyclohexane 1-ol you will get. Is it clear? And the mechanism it has followed the SN1. Mechanism it has followed the which one? SN1. Is it clear? Darshan, good Nana. Now, right. Next one. Last one I will stress. Last one I will give you the one question and I will stop the SN1 SN2. This is a one very important reaction. Okay, last question. Okay, next. This is 2, this is 1, this is 2, and the 3. Both all. For which exam I was teaching? I was teaching for JEE Mains, Advanced as well as NEET. All it is included, Nana. It is not for only one. My teaching is for the all the entrance exam, not only particular for one. Darshan, you need any particularly for which exam you are preparing? For which exam you are preparing? Darshan, for which exam you are preparing? SN2 reaction happen very fastly in. Among the 1, 2, 3, 4, SN2 reaction happen in very fastly in. SN2 reaction happen in very fastly in. 2, 3, 4, 1. Okay. I was teaching for all. Darshan, I was teaching for the mains, NEET as well as for the advanced, because content is same for all. Content is same for the which one? For the mains and the advanced as well as the NEET, content is same, but level of the questions are different. First small basic level, next high level or moderate, high, and tough questions. That in that manner I was stressing the questions. So from the basic level 2 I was stressing the questions. It will be sufficient for your NEET. I can say you that for your NEET exam for chemistry it is very sufficient for you. Okay, try to follow the lectures daily, try to attend the live class daily, and daily already I was posted in the community tab the schedule of the class. Now what is the time and all, once you can cross check over there. Pranit, whatever the order you have said, that is wrong. Pranit, whatever the order you have said, that is wrong. Whatever the order you have given, it is wrong. Nocylate is a good living group, that is okay, but whatever the order you have given, it is wrong. Whatever the order you have given, it is wrong. Nocylate is a good living group and it is okay, but the order which you have given, it is wrong. Can you cross check? Can you cross check the order once again? Rest other, my dear friends who are in the live, try to give me the answers. Your comments and your chat will give me boost so that I can give you more content. See, in my personal time also I was explaining and I was taking the classes for you. If you are following, so that if you give the answer and if you are trying something, so that it will make me happy. So something I was giving to my students, it will make me feel happy. No, the answer is 2, 3, 1, 4. Good. Why? Because here this is a nocylate. Nocylate is a good living group, because due to the strong -M, that oxygen negative charge is stabilizing by the -M. Then here the Br is a -I. This Br, it will take this bond pair of electron and the -I will be stabilized. But here this is methyl. Methyl is a +H, and this oxygen negative charge with the +H somewhat less stable. And here it is a neutral. This is a basylate. This one is a basylate. This is basylate. This is a nosylate. Nosylate is a good leaving group. Now this is a brosylate. This is a brosylate. Now next to the tosylate. My dear Ansh, let me finish the E1, E2, E1 CB very fastly. Then at the last, once the class has finished, in this live session only, I will continue the mesomeric effect for you. Okay, I will continue the mesomeric effect for you, because the mesomeric effect is not an that much easy topic to explain you in very less time, because it is having the vast application. With the vast application, I will explain very clearly. Sir, if you are having the any confusion, means already I did the very beautiful lecture of the mesomeric effect in my channel. Once you go, you can visit over there, or else in the last I will explain very clearly with n number of examples. Okay, let me finish this session. Okay, is it okay, Ansh? No. Okay, fine, done. Now we'll move to the next type of the reactions, that is SNI. Next type of the reaction, that is SNI, nucleophilic intramolecular reaction. Nucleophilic intramolecular reactions also, it is very important. Now how it will give you, now we'll see. Here it is a H, now it is having the D, now here it is a alcohol. Okay, now with the thionyl chloride, this is thionyl chloride without base. Thionyl chloride without base, retention product will get. Okay, now this is also sometimes they will stress with the IUPAC. Thionyl chloride without base, if they have given, what is the product you will get? You will get the retention product. Done. Next, the same substrate, thionyl chloride in the presence of pyridine, in the presence of base. Thionyl chloride in the presence of the base, what it will get? You will get the inversion product. Now this is the inversion product. So you have to be very careful whenever the thionyl chloride, whenever the alcohol and the thionyl chloride, if they have given, they will ask you thionyl chloride without base. Now what is the product? And thionyl chloride with base, what is the product? Done? Clear? Now we'll see the mechanism. Thionyl chloride without base, first one. Mechanism for the thionyl chloride without base. Now thionyl chloride without base. Now how the thionyl chloride will be? SOCl2. Thank you, Pranav. Thank you. This type of the messages, it will be boost for me, so that I can give you the more content, and try to follow the daily live classes also. Clear? Now here this is a thionyl chloride. Now this thionyl chloride, this oxygen lone pair of electron will be abstract this sulfur. Why? Because this sulfur being the electron deficient, and this bond pair of electron will be shifted toward the oxygen. Then what it will get? Here the pH, and here the H, and here it is a D. Now the oxygen will get the positive charge, and here it is a H. Okay, now here the O, oxygen O minus. Now here it is a Cl, and here it is a Cl. Okay, I am ready to help you, Pranav, wherever you are getting the problem in your organic chemistry, that I am ready to explain for you. Sir, I am ready to, whatever the doubts you are having, that I can ready to explain for you. Done. Next, this oxygen negative charge, again it will be delocalized, and the chlorine being the what? Chlorine being the which one? Here also this oxygen being the positive charge, what it will happen? It will take this bond pair of electron and it will get neutralized. Then after getting the neutralized, wait, let me write this one. When oxygen, when it has taken this bond pair of electron and when it has got neutralized, then this sulfur, here it is having the negative charge and here it is a Cl and here it is a Cl. Then what it will happen? This oxygen, this negative charge, it will be delocalized. Now this chlorine being the good leaving group, it will be added to this chlorine and this bond pair of electron will be eliminated, and this bond pair of electron has been eliminated, because here as a which one it will be eliminated? Now listen, sorry, not, it will not attack in this manner. Wait. Now you see, here when this bond pair of electron has been shifted here, now the chlorine being the good leaving group, it will be eliminated. Now when the chlorine being the good leaving group, it has been eliminated. Now here it is a hydrogen and here it is a deuterium. Now the oxygen, now here the sulfur, double bond O and the Cl. Now you see, here this bond pair of electron of this oxygen, when it has shifted here, now this chlorine being the good leaving group, it will go and attack from here. Why? Because why it has eliminated? Because SO2 is a neutral gas and it is stable. As a SO2 gas, it will be eliminated, and wherever the leaving group it has been eliminated, from that side itself, now nucleophile has been added. That's the reason we will get the retention product, in which case? Without base case. Now we will see with base case, the same mechanism in the presence of base case if it is given. Okay, now in the presence of thionyl chloride, in the presence of base, if they have given, this is a base. Now if suppose the base if they have given, now first what it will happen, this thionyl chloride, whatever the base, first here the pH, CH, here it is a D. Now same thing, whatever the first in this reaction, whatever we have did, up to here it will be same. In the thionyl chloride, up to here it will be same. Here the S double bond O, directly I was adding nana. So not to get any confusion, same thing. First this oxygen lone pair of electron will be abstracted this sulfur and bond pair will be shifted here. Then oxygen will get the positive charge and this positive charge will be stabilized by this hydrogen, sigma bond pair of electron. Then again this negative charge will be delocalized and the chlorine will be eliminated. Again this product only will be generated. Done. Then after that, here the base we are having, right? Now this is a pyridine. Now pyridine, this lone pair of electron will be given to this deficient sulfur very fastly. When it has given this deficiency sulfur very fastly, then what it will happen? Again here the pH and here the H and here it is a D and here the oxygen lone pair of electron and the sulfur O minus. Done. And again here we are having the nitrogen, it is bearing the positive charge because the pyridine has given its lone pair of electron, and we are having the Cl Clear? Then when this bond pair of electron has been shifted here and this chlorine will be eliminated first. This chlorine will be eliminated. When this chlorine has been eliminated, it is not having a chance to attack from here. Then what it will happen? It will be attacked due to this bulky groups present. It will be attacked from the back end. From where it will attack? It will not attack from the front end. It will be attacked from the back end. First it will be attacked from the back end and this leaving group will be eliminated. And what we will get? Retention or inversion product will be get. Here the H, here the D, and here it will get the pH. Clear? Now which one? Inversion product will get. So thionyl chloride in the presence of base, inversion; without base, retention. Clear? Now what are the products or which mechanism it has followed? Now you have to say me. If suppose Br if they have given, Now, one OH minus HMPA. HMPA. Now, OH minus alcohol. Right. Not right. Then we'll take the H2O. Better. Now, which mechanism 1 has followed, which mechanism 2 has followed? Try to semi fastly. Which mechanism 1 has followed, which mechanism 2 has followed? Try to semi fastly. Which mechanism 1 has followed, which mechanism 2 has followed? Try to semi fastly. Which mechanism 1 has followed, which mechanism 2 has followed? In the second question also, which what is the product in the first one and what is the product in the second one? Can anyone? Can anyone say me the answer for this one? Can anyone say me the answer for this one? Second one is SNI. Second one is SNI. I mean, you are saying for the second one, second question, or for the first one you are saying? Pranit, second one is of which one? Second, first one SN2 I think. First one is SN2. First one is SN2. In second question, sir. In second question, here this is SN1 for okay. This one is okay. Now you say me the second question. First question 2 is SN1. Yes, good. First question 2 is yes, and good. First question 2 is SN1 and first question 1 is SN2. Now second question, we'll take the A and B. If you are getting confusion with the 1 and 2 means we'll take with the A and B. We'll take with the A and B. I will give you this as a and I will give you this as a B. Second question A. Second question A, inversion product, retention product. Second question A, inversion product, retention product. Second question A is inversion product or retention product. Fastly, fast ga. Second question is retention. Good, Ansh, good. Now, second question B. Second question B. Second question B is inversion. You know, sometimes thionyl chloride with the A retention, B inversion. Good, good. Sometimes they will give you the which one? Diethylamine. Diethylamine is more basic than the which one? More basic than the pyridine. Try to believe. This is very, very important. Okay. This is oh wait, I was written this. Triethylamine. Triethylamine. This is a triethylamine. This is triethylamine is a more basic than the which one? Pyridine. Clear? Done. Right. Right. Now we'll move to the next one. SNI is clear. SNI is clear. Now we'll go with the SNNGP. Next, another type of the reaction we are having, that is SNNGP. SNNGP is nothing but neighboring group participation. So to show this neighboring group participation, so listen, first one, to show the SNNGP is intramolecular. This is intramolecular SN2 reaction. This is intramolecular which reaction? SN2 reaction. Okay. Now what are the key points to show the SN-NGP? Next one, internal nucleophile. Whatever the internal nucleophile it is there, internal nucleophile should be present in the compound itself. In the compound itself it should be present. Done. Next one, external nucleophile. External nucleophile concentration should be less. Okay. Now this SN-NGP is faster than SN1 and SN2. Then this SN-NGP is 2 times of SN2. 2 times of SN2. Intramolecular reactions are faster than the intermolecular reactions. You have to be very careful. So in which compound examples of the SN-NGP absorbed? In which case SN-NGP is absorbed with these nucleophiles. SN-NGP will be absorbed only with these nucleophiles if they are present. If they are present in the compound, or if they are present in that substrate. If these nucleophiles are present in that substrate, first one is a OH, O minus, now SH, clear. Now thiol, done, S minus, clear, it is having the S minus. Next one NH2, NH minus. Next C double bond O minus, halogens and the pi bonds. Now if these are present, now it will show the SN-NGP. Now how the SN-NGP it will be happen, now we'll see how the SN-NGP will be happen. Now we'll see. Now I was taking the one example of CH3 S sulfur with the lone pair and the Cl2, and here it is a one carbon isotope of 12 and it is a one leaving group Cl. Clear? Done. First what it will happen, first this lone pair of electron, of this sulfur, it will form the which one? Intermolecular SN2 reaction. From the back end nucleophile will be added to this carbon and this Cl will be eliminated. When this Cl has been eliminated, now what it will get? Now the product will get in this manner. CH3, now here the sulfur with the positive charge, and here it is a CH2. Now here it is a isotope carbon. This is a carbon isotope carbon. In this manner it will form. Done. After that, when it has formed this one, now OH minus, if the one nucleophile it is there, here this OH minus it is having the two chance to attack. If it is attacked from this carbon, now this bond pair of electron will be given to this sulfur again. Now what we will get? Now what is the product we will get? In this manner we will get. If it is attacked to the 1 number carbon and this is a 2 number carbon. If it is attacked to the 1 number carbon, now what is the product we will get? CH3 S, and this is a isotope carbon, and here it is a CH2 and it is a OH. Done. If suppose if it is attached to the 2 number carbon, then this bond pair of electron will be shifted towards the sulfur. If this is 1, when it has attacked to the 2 number carbon, this is CH3 S, it is S, then here it will, what you will get? CH2, and this is a carbon isotope 1 and this is a OH. Clear? Now this is a which one? SN-NGP. This is SN-NGP. Done. Now we'll have some questions based on this one. Now next, if suppose any cyclic ring if they have given, if any cyclic ring if they have given, now here the sulfur and here it is a pH, now here it is a H and here it is a H, now here it is a Cl. Now the sulfur it is having the lone pair of electron, right? Now here the what it will form? Now intramolecular SN2 reaction it will form. When it has formed the intramolecular SN2 reaction, first in this cyclic transition state it will form here. Clear? Here it is a H, here it is a H. Then OH minus it is there. This OH minus, when it is abstracted here, now this bond pair of electron will be shifted towards the sulfur. Now the sulfur again its lone pair of electrons will be restored. Now here it is a H, now here it is a OH. Clear? In this manner retention product will get. First is the inversion, next is a retention. Done? Is it clear? Everyone up to now? Up to now SN1, SN2, SNI, SNNGP. Clear, right? Clear, right? Is it clear for everyone? Now I am going to start the elimination reaction. Now elimination E1, E2, E1 CB. E1, E2, E1 CB it is there. Now after that comparison SN1, SN2, E1, E2 comparison questions, and we'll try to finish. Okay, it's already 9:17. Now max to max I will try to finish it by 10. Okay, max to max I will try to finish it by 10. Now listen carefully. Try to give me the answers very fastly. If you know, give the answers. If not, give me the question mark. Okay, right. Next category we are going to start with the elimination reactions. Elimination reactions. Okay, done. Here the elimination reactions. Now most of the elimination reactions, here we'll see how the elimination reactions will be happened. First, what are the conditions to show the elimination reaction? Now to show the elimination reaction, now if any strong base it is there, here the elimination reaction, now here we are breaking the one sigma bond and one making the which one? What we are making? We are breaking the one sigma bond and we are making the one weak pi bond, right? So that's the reason we have to give the energy. So the delta H is positive. Then if the delta H is positive, then here the one substrate it is converting into the 2, right? From the HX it is eliminating. When the HX it is eliminating, 1 it is converting into 2. So the delta S is positive. That's the reason if the delta H is positive and the delta S is positive. Now thermodynamically, here in the elimination reaction, first we are breaking the one strong sigma bond and making the what? One weak pi bond. Then after that HX is forming. Here in this case we have given the energy, right? So the delta H is positive. Now 1 is converted into the 2, right? So the delta S is also positive. Now the delta G is equal to delta H minus T delta S. We know any reaction to be happened, delta G should be the negative. If the delta G is negative, reaction will be happened very fastly. Then here the delta H is positive. Now the delta S, here the delta S is also positive. Positive into negative, it will give you the negative value. But overall reaction to get the negative, here the temperature will be deciding factor. If the temperature is very high, then this overall value will become more negative. Let's suppose I was given the 300 kilojoules of energy to break this bond, and here entropy it has formed the very stable, and it is, let's suppose here it is a 200, arbitrarily we are taking, arbitrarily. Then here the temperature, let's suppose here the temperature is something, high temperature will play. If the high temperature, if they have given, high negative will get, high negative, less positive into high negative, overall will give you the delta G. Means high temperature is required for the elimination reaction. This is the first criteria. In the first criteria, why the elimination reactions high temperature is required? Because its delta G is favorable only at the high temperature. If you give the high temperature, what it will happen? This overall delta S value will become negative. Then this overall delta G factor will become negative, and that's the reason elimination reactions, what? High temperature is required. Is it clear? Is it clear for everyone? Done? No. Right. Next. Here, now in the elimination reactions, the first elimination reactions we are having the two types. Now in this elimination reaction, the first we are having the two types. One is unimolecular elimination, that is E1. Now next one, bimolecular elimination reaction, that is E2. Done? Now here in this unimolecular elimination reaction, 1, 2 are beta position, 1, 2 are beta position, either elimination reaction in which either atoms or groups eliminated. Here the 1, 2 are beta position, atoms are groups will be eliminated. Atoms or groups will be eliminated. Atoms or groups will be eliminated from the 1, 2 are beta positions. Done? Now first one will go with the E1. First reaction we are going with the E1. Now in this E1, what are the favorable conditions to show the E1? First is 3 degree alkali halide. 3 degree alkali halide. Done. Next, 3 degree alcohols. 3 degree alcohols readily undergoes E1. What? Readily undergoes E1. Next, these are non-concerted. These are non-concerted. What is the meaning of the non-concerted? Intermediate is present. Intermediate is carbocation. Carbocation is a intermediate. Clear? Next, polar protic solvent is used. Polar protic solvent is used. Done. Next, rearrangement of carbocation takes place. Rearrangement takes place. TP means takes place. Done. Now here, now we'll see how the E1 reaction will be happen. Now the CH3, now one CH3, now here it is a one CH3. Okay, now here it is a hydrogen, now here it is a hydrogen, now here it is a CH2, and here it is a OH. Okay. Now if it is a primary alcohol with a concentrated H2SO4, upon heating at a high temperature, from this concentrated H2SO4 will get the H plus. Now this H plus, this oxygen lone pair of electron will be abstract this proton. Then what it will happen? Now this is a CH3, now here it is a CH3, now here it is a CH3, now here it is a CH, now here it is a C, and here it is a H, and here it is a H, and it will get the what? Oxonium ion. What is the oxonium ion? Now this is a oxonium ion. Done. Now OH is a bad leaving group, but making the bad leaving group into the good leaving group, how? This oxonium ion, by taking this bond pair of electron, H2O is a weak base and it will be eliminated as a good leaving group. When it has eliminated, now we get the carbocation. Now in the SN1 reaction, in the E1 reaction, now carbocation is the intermediate. Now here we got the carbocation. In the E1 reaction, what I said, carbocation rearrangement will be takes place. So 1 comma 2 hydride. Hydride, if I am saying, means it is going with the bond pair of electron. Hydrogen is going with the bond pair of electron. Then when the 1 comma 2 hydride shift happened, when the 1 comma 2 hydride shift has been happened, now this carbon will get the positive charge. This carbon will get the positive charge. Okay. Then when this carbon has got the positive charge, you may think that, sir, here this carbon is a 3 degree carbocation. Now it has came to the more stable carbocation. Right. But here still if it is came to the 3 degree carbocation, but its alpha hydrogens are only 3 alpha hydrogens. This carbocation still it has came to the 3 degree, sorry, it has came to the 2 degree, sorry, I thought this is a carbon. Oh no, sorry. Now it has came to the 2 degree carbocation. Now 2 degree carbocation is somewhat less. Still we can make the more stable carbocation by 1 comma 2 hydride 1 comma 2 methyl transfer. When we have shifted this 1 comma 2 methyl transfer, now this carbon will get the positive charge. Now here it is a carbon, we are having the hydrogen. Now here it is a CH3. Now here it is a CH3. Done. Clear? Now after getting the more stable carbocation, then what it will happen? Here it will be the product will be decided on the basis of how? Now here it will be decided on the basis of the carbon which gives, which one? Now the alkene which gives more what? The alkene, the hydrogen will be eliminated from that carbon which gives the stable alkene. Now you have to say me, now the hydrogen will be eliminated from the 1 number carbon or 2 number carbon or 3 number carbon to give the more stable alkene. To give the more stable alkene, hydrogen will be eliminated from the 1 number carbon, hydrogen will be eliminated from the 1 number carbon or 2 number carbon or 3 number carbon. Now you have to say me 1 number carbon, because 1 number carbon if it is eliminated, it will give you the more stable alkene, and this more stable alkene we call it as a Sedgwick alkene, more substituted product. It will call it as a Sedgwick product. Now if it is eliminated from the 2 number carbon, now it will give you the Hofmann product, that will call it as a which one? You can see this alkene is having only here 3 and 1, only 4 alpha hydrogens, but this alkene is having total 12 alpha hydrogens. So more alpha hydrogen containing are more stable. So this is more stable. This is more stable. Clear? Done. Now next we are going to see, this is about the which one? This is about the E1. E1 more stable alkene is a product in the E1. Next E2 will take E2 bimolecular elimination. In this bimolecular elimination, 3 degree alcohols are 3 degree due to hyperconjugation. Good. 3 degree alkali halides. 3 degree alkali halides undergoes E2 elimination. Clear? These are concerted reactions. Okay, these are concerted reaction. Okay, right. Now here this E2 reaction, rate of the reaction depends on eliminating group as well as the base. Eliminating group and the base. Clear? Here the very important, many of the students they will get confused. Trans elimination are anti-periplanar elimination takes place. Anti-periplanar elimination takes place. Done. Now with the strong base, E2 reaction will readily takes place. With the strong base, E2 reaction will be readily takes place. Now with the two types of the base, I will explain. So here there is no any mechanism it is involved. With the two types of the base, readily I will explain. Here the hydrogen, here the hydrogen, here the hydrogen. Now here the hydrogen, now here the hydrogen, here the hydrogen, or here the one leaving group it is there. Leaving group is a one Br. Okay. Now here it is a hydrogen. 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 Okay. Now small bases NaNH2. These are the strong bases. NaNH2, alcoholic KOH. Okay. This NaNH2, when it is abstracted, when it is abstracted the internal hydrogen, then it will form the in this manner. What it will form? Now that bond it is forming, the bond it is making, bond it is forming, the bond it is leaving. Here in this transition state it will form. In this manner the transition state it will form. In this manner the transition state it will form. This bond will be shifted here. Now when this bond has been shifted here, what it will happen? Now you will get the more substituted alkene. More substituted alkene you will get. More substituted alkene. Clear? The more substituted alkene is called as a set job product because these are the small bases. These are the small bases. It can readily abstract the which one? Internal hydrogen. But if suppose if they have given the tertiary butoxide, this is a tertiary butoxide. Tertiary butoxide is a bulky base. This tertiary butoxide is not having a chance to take the internal hydrogen. Sir, which is anti, right? Now it is not having the chance to take this internal hydrogen. Why? Because these groups will repel this bulky base. So that's the reason what it will happen. Now this bulky base will take the hydrogen or proton from the which one? It will take from the internal or terminal end. When it has taken from the terminal end, and it will give you the half-mined product. It will take this from the terminal end. Now it will form and the Br will be eliminated. Here the CH2 and here it is a CH3. Sir, alcoholic KOH also give you an S. Alcoholic KOH, the strong base if it is there, it will give. That is depending upon the substrate we have taken. I will explain which one will give you the E1, which one will give you the E2, when the E1 will play very crucial role, when the E2 will play, where the substitution will happen, where the substitution will not happen, I will explain. Let me finish this one. Let me finish this topic first. Okay? Okay? Now with this only one thing you have to remember. Alkali halide in the presence of small base, set job product. Now alkali halide in the presence of bulky base, half-mined product. Only one thing you have to remember. Done? Next one we are having. Next another type of the reaction that we are going to see, that is E1CB. That is E1CB. What is the E1CB? Darshan, whatever the doubts you are having, that I will explain at the last. Now, but that with this one also very clearly alcoholic KOH where it will be useful, that all we know. Now next one, elimination conjugate base, E1CB. Now here the E1CB, what are the where the E1CB will be happen? Electron withdrawing group containing alkali halides or alcohols readily undergoes. Alcohols readily undergoes. First thing. Second thing, these are non-concerted. These are non-concerted reactions. Okay, here very important is intermediate. Intermediate is carbanion. Next, rate of the reaction depends upon both substrate and base. Substrate and the base. Clear? Sir, give me the quick revision of nucleophilic substitution. Nucleophilic substitution, it will not happen now. At the end I can give. Now, next one, here how the reaction will be happen, now we'll see. Here the CH3, now here H, here it is a CH3, now here it is a F. Now whatever may be the nucleophile you have taken, alcoholic KOH or tertiary butoxide. Alcoholic KOH you may take or tertiary butoxide you may take. Either you may take the bulky, either you may take the small. What it will happen here, if you take this base when it is from the internal hydrogen, let's suppose here the fluorine. Now the fluorine is a bad leaving group. Fluorine being the bad leaving group, now what it will happen, now in this periplanar elimination will not be happen, or anti-periplanar elimination will not be happen, because fluorine being the bad leaving group, it will not be eliminated. So that's the reason what we have to do, we have to make the carbanion, because base will readily abstract the proton, so that it will get the carbanion. If this base, if it is taken the hydrogen from the internal end, then we will get the which carbanion? 2 degree carbanion. This one is a 2 degree carbanion, it will be provided if the base, if it has taken the internal hydrogen. If suppose if this base has taken the terminal hydrogen, which it is there here, if the hydrogen, if it is taken from the terminal, from this terminal position if it is taken, then what it will happen, from the terminal position when it has taken, it is providing the which one? 1 degree carbanion. Among the 2 degree carbanion, among the 1 degree carbanion, which is more stable? Among the 1 and among the 2, which is more stable? Can anyone say which is more stable among the 1 and 2? Among the 1 and 2, which is more stable? Which intermediate is 1 degree carbanion is more stable? If the 1 degree carbanion is more stable, now this will be delocalized and the fluorine will be eliminated and will get the off mined product only. In the E1CB, whenever the what? Whenever the which one? Whenever the halogens they have given, now fluoride if they have given, now fluoride being the bad leaving group, it will not leave from the substrate very fastly. First we have to make the intermediate. Which one? Carbanion as an intermediate we have to make, and the off mined product is a major. Now we'll see the energy profile diagram for it. Now the energy profile diagram, if you see for the which one? If you see for the reaction, first alkali halide, now formation of the carbanion is a fast step. Formation of the carbanion is a fast step. Now this is a fast step. Sometimes they may ask in the E1CB mechanism, now which is the fast step? Formation of the carbanion is a fast step. Then after that, now the formation of the product is a slow step. This is a slow step. Clear? Now right. Now this is a which one? Up to now CMR. Now the one who are in the live, once you text me hi, now the E1, E2, E1CB has been done. Now we'll see the comparison. Now SN1, SN2, E1, E2. Now which one will give you the SN1, which one will give you the SN2, where the SN1 will be dominate, where the SN2 will be dominate. Pranit is there. Rest any other who are in the live, once you give me the hi, so that within 20 minutes or within 25 minutes we'll finish the all type of the SN1, SN2, E1, E2, E1CB questions. Now whatever the confusions you are having, that I will make you clear. Ansh, good, Ansh is also there. Now listen to the class carefully, Nana. Where to use the SN1, where to use the elimination. See, alkali halide, SN1 it will substitution, it will undergo elimination it will undergo. Darshan is also there, good. Now, where to use the elimination, where to use the substitution, now I will explain with the which base are, where it will, because sometimes all the bases will be act as a nucleophile. In the same way, all the nucleophiles will act as the bases. Now, comparison between SN1, SN2, E1 and E2. Okay, SN1, SN2, E1, E2. Here the first point is all nucleophiles and base, all nucleophiles acts as base. All bases acts as nucleophile. This is the one key point you have to remember. So how to decide? This one, next point, alkali halides. Alkali halides undergoes SN1, SN2, E1, E2 and as well as E1CB. Okay, SN1 it will alkali halides, SN1 it will undergo, SN2 it will undergo, E1 it will undergo, E2 undergo, E1CB it will undergo. Then how to decide? Which one will play very crucial role? For that one, if the alkali halide, if they have given high temperature, if they have given, first key point, high temperature with the alkali halide with high temperature, if they have given, elimination is a more dominating. Elimination. Low temperature, if they have given, substitution is more dominating. Elimination, if they have given, high temperature elimination, low temperature substitution. Done. Now leaving groups like SN1, SN2 reaction, the rate of the E2 reaction is indirectly related to the leaving group ability. Okay, the strong acid conjugate bases are the which one? Weak bases and the good leaving groups, right? Now here, now we'll see with the 3-degree alkali halide. If suppose 3-degree alkali halide is there, 3-degree alkali halide if they have given, which reaction is favorable for the 3-degree alkali halide? Which reaction is favorable for the 3-degree alkali halide? Elimination or substitution? If it is elimination, E1 or E2. If it is substitution, SN1 or SN2. Now 3-degree alkali halide if they have given, SN1 it will readily undergo, E1 also it will readily undergo, because in both the cases carbocation is the intermediate. In the SN1 and SN2, intermediate is carbocation. Okay, SN1 it will undergo, SN2 it will undergo, E2 also it will undergo, and it is good. But how to decide for this 3-degree carbocation if they have given, 3-degree alkali halide if they have given, how to decide SN1 favor? Ikkada SN1 is, it will give, E1 it will give. But how to decide whether the SN1 is high priority or SN2 high priority? How to decide? If suppose this 3-degree alkali halide if they have given, okay, 3-degree alkali halide, 2 reactions it will undergo, one SN1 it will undergo and one E1 it will undergo. Then how to decide whether which one is a high priority? Base check. Okay, base is also one factor. Okay, fine. Other than base, one key point you are missing. One very small key point you are missing. Product and కాదు, ఒక చిన్న కీ పాయింట్ మిస్ చేస్తున్నారు. వీక్ న్యూక్లియోఫైల్ ఫర్ SN1, స్ట్రాంగ్ ఫర్ SN2. Condition, one beautiful condition you guys are missing. Temperature. Yes, good Darshan, good. temperature, low temperature SN1, high temperature SN2. Temperature. If the 3 degree alkali halide, if they are given, temperature will play very important role. Yes, good. Temperature if they are given, low temperature SN1, high temperature SN2. Sorry, high temperature E1. Is it clear? Still any confusion? Good. Okay, done. Now, right? Raza. Okay, right. Good. Next one. Next will go. Now, here with the 2 degree alkali halides if they are given. If 1 degree alkali halide if they are given, 1 degree alkali halide, 1 degree alkali halide if they are given. Okay, this is 1 degree alkali halide. Here 1 degree alkali halide, which reaction will be favorable? For the 1 degree alkali halide, which reaction is favorable? Both. One is SN2 is favorable, one E2 is favorable. SN2 is favorable and E2 is favorable. When other than temperature condition, which one is more favorable? ఒకటి SN2 ఇస్తుంది, E2 ఇస్తుంది. కానీ SN2 ఇస్తుంది, E2 ఇస్తుంది. Among the SN1 and the SN2, which is more favorable? E2 is favorable. SN2 with low concentration base. SN2 will readily undergo with low concentration base. E2 with high concentration base. But my question is, this is one alkali halide they have given. Alkali halide if they have given. Okay, alkali halide if they have given. Alkali halide with same strength. ఒకవేళ concentration of the SN2 and the concentration of the base whatever the we have taken, nucleophile the base the concentration same ఉంది అనుకో, how to decide which one will give you the more product? ఏది డిసైడింగ్ ఫ్యాక్టర్ ఎక్కువ? E2 డిసైడింగ్ ఫ్యాక్టరా లేకపోతే E2 డిసైడింగ్ ఫ్యాక్టరా SN2 డిసైడింగ్ ఫ్యాక్టరా? My dear friends, readily below here, whenever the 1 degree alkali halides they have given, SN2 product is the more favorable than the E2. 1 degree alkali halides ఇస్తే, 1 degree alkali halides ఇచ్చిండంటే most of the cases favorable condition product is SN2, not E2. Okay, more favorable condition for the product to be happen in the nature of living group unna kuda, the very important point for the 1 degree alkali halide they have given, 1 degree alkali halide will favor for the SN2 mechanism only. For the E2, for the elimination reaction to show 2 degree position and the 3 degree positions a leaving group, if it is there, it will readily show the E2 elimination or elimination it will show. Okay, favorable condition for the 1 degree alkali halide if they have given, favorable condition is SN2 only. Most of the cases favorable condition is SN2 rather than the elimination. Clear? Is it clear? Now let's suppose 3 degree alkali halide they have given. 3 degree alkali halide if they have given, 3 degree alkali halide if they have given, 1 degree alkali halide most of the cases favorable condition is which one? Most of the cases is SN2. Now the depending upon the nature of the base, then we have to decide it for the E1. Next, here it have taken next sodium ethoxide. Okay, sodium ethoxide at something 55 degrees Celsius. and sodium ethoxide at something 20 degrees Celsius. Now what are the product we'll get it in A and what are the product we'll get it in the B? What are the product we'll get it in the A and what is the product we'll get it in the B? What is the product we'll get it in the A and what is the product we'll get it in the B? What is the product we'll get it in the A and what is the product we'll get it in the B? What is the product we'll get it in the A and what is the product we'll get it in the B? E1 and SN1. E1 and SN1. E1 and the SN1. E1. Elimination is more favorable. Here the elimination is more favorable. Low temperature and at the less temperature substitution. Okay. Now here in this manner we have to decide which one will be the more favorable. But here it is not the which one na 3 degree alkali halide upon the strong base they have given. It is not E1, it is E2 elimination. It is not the E1 elimination, it is E2 elimination. And you have to be very careful here. Whenever the 3 degree alkali halide they have given and when they have given the strong base, whenever they have given the strong base, now here it is the E2 elimination, not E1 elimination. This is SN1 only. This will give you the SN1 only. But whatever the elimination product we will get, that is not of E1, it is of following the E2. Okay? Is it clear? Is it clear? Yes sir, okay, fine. Now here which one will give you the, which base will give you the Hofmann product, which base will give you the one stereochemistry questions with this one. Now you have to say me, let's suppose one question I will give you. Now you got it right, where to decide the 3 degree alkali halide, where to decide the SN1, where to decide the SN2, where to decide the SN1 and where to decide the SN2. Now you can see SN2 reaction is favorable by the 1 degree alkali halide, 2 degree alkali halide and the 3 degree alkali halide. Now E2 reaction is favorable by the 3 degree alkali halide, 2 degree alkali halide and the 1 degree alkali halide. Okay. Now these two are the concerted reactions. These are concerted reactions. Next, when it comes to the SN1 is favorable by the 3 degree alkali halide, 2 degree and 1 degree. And E1 3 degree, 2 degree and 1 degree alkali halides. Clear? Now in this case these are the non-concerted reactions. These are non-concerted reactions. But here the favorable conditions for the elimination group should be the 3 degree alkali halide for the E2, SN1 and the E1. Is it clear? Is it clear for everyone? Now here, now I will write the one question. Now one question I will give you. Now you have to say me the product name. Okay, you have to say me the product name. Now say me the product name. What is a product name? What is a product name? The one who are in the live, try to say me the product name. Try to say me the product name. What is the product name? What is the product name? 6, 6, 6, 6, undecane. Decana. Pranit, once you cross check. Once you cross check. Once you cross check. Decane, but my dear, Kani, which reaction this is? H plus and heating if they are given. Which reaction? Pranit, H plus and heating if they are given. Which reaction? H plus and heating if they are given. Which reaction? H plus and heating is the which reaction it is? Elimination. Now in the elimination, what is the product will be? Alkana, alkena. Alkana, alkena. In the elimination, what is the product? Product is alkane or alkene? Alkene. Then how come it will? How come the spiro 6, 60 undecane you get? Undecane you how you will get the undecane? Ane how you will get? How you will get the undecane? Ring expansion will happen. Wait, I will explain. Now here this H plus oxygen, this lone pair of electron will abstract this proton. When this lone pair of electron, when it has abstracted this proton, then here it is a 6-membered ring. This 6-membered ring, here this carbon will get the positive charge. When this carbon it has got the positive charge, then this 5-membered ring will be 5-membered ring. To get more stable, it will be moved to the which one? It will move to the 6-membered ring. Then what it will happen? Here this is a 1-number carbon, 2-number carbon, 3-number carbon, 4-number carbon, 5-number carbon. Now this 5-number carbon, this bond pair of electron will be shifted towards the 6 or 5-number carbon. Then the 5-number carbon will get the negative charge. Done. Now here it is a positive charge. Here it is a 6-membered ring. Clear? Now this 1-number carbon will get the positive charge now. Now this 5-number carbon, 4, 3, 2, 1. This 5-number carbon and the 6-number will form the ring. Now give the numbering 1, 2, 3. Now how the 6-member rings will be happened like this. Both will be form the 6-member ring. When both the 6-member ring it has happened, now this 1-number carbon it is having the positive charge. Okay. Now it is having the positive charge. Here this carbon does not having any hydrogens because 4 bonds happened. 1, 2, 3, 4. Now here only the hydrogens will be eliminated. Now it will give you the alkene. Now it will give you the alkene in this manner. Now you can see both the cases. This is a spiro. In this spiro, from the low carbon path to the high carbon path will move. Here here it is getting 1, 2, 3, 4, 5. Here it is getting 1, 2, 3, 4, 5. So both the cases carbons are same. Then we have to give the numbering that alkene should get the least number, right? This is 1. No, not this one. This one is a 1, right? Now this one is a 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So now the IUPAC name will be the spiro. How many carbons? Undecane, 1 in. Spiro, undecane, 1 in. Is it clear? Spiro, undecane, 1 in is a compound. Is it clear? Okay, done. Next question. This is very, very important. Now they are stressing with the which one? Stereochemistry. Now alcoholic KOH heating. Now A is the here it is a hydrogen. This is A. B option. This is B. Okay, B. Next C. This is C. And D, none of the above. What is the option? What is the option for this one? What is the correct option for this one? What is the correct option for this one? Sia. Or what is the correct option for this one? Option C. No, not Darshan. Option C is correct. Option C is correct. See, whenever this type of the questions, good Pranit, good. Because this Cl and the hydrogen should be trans to each other, but this hydrogen they will not give you in the question. So here this hydrogen and this chlorine is cis to each other, but this hydrogen and this chlorine is trans to each other. So the trans elimination will be happened in the E2, right? So the hydrogen will be eliminated and the Cl will be eliminated and the C will get. In this manner we will get the C. Okay? Right. Now next one. Next question you try. Next question. Next question. Now what is the answer? None of the above. What is the answer for this one? What is the answer for this one? What is the answer for this one? A. Everyone who is in the live, try to give me the answer. Try to give me the answer for this one. Answer is A. Good. because here these are the hydrogen which is present here will be the trans to Cl. Okay, here also one hydrogen will be there, here the trans to Cl. Because here this one it will give you the less, here 1 2, here it is giving 3 alpha hydrogens, here it is giving 1 2 3 4 5 6 alpha hydrogens. So one A is more stable. Good. Next. Now here it is a CH3, here it is a Cl, now here it is a CH3, here it is a H. Now alcoholic KOH upon heating, what it will give? Now which one will be the correct? This is A. Now B. Now this is B. This is C. Among the A, B, C, which is correct? 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 B. Oh my dear, B. Pranit, once again you cross check. Both are on axial. Both are on axial, what happens? If both are on axial, what it is happen? 1, 2, cis is AE, trans is E or AA only, right? Now this chlorine and this hydrogen is trans to each other only. For 1, 2 position, this is 1, 2 position, this is A, this is A, both are in, means Cl and hydrogen both are in the, then both are in the trans to each other only, right? Then this sigma 1 it will go and it will give the more number of alpha hydrogens. So A is more stable. So why you are getting confusion? Why you are getting confusion? So this type of the molecules will play a very, very crucial role. You have to be very careful with this type of the molecules. Okay. Next, if suppose Fisher projection they have given like this one Fisher projection if they have given. If Fisher projection they have given, Fisher projection with alcoholic KOH, heating. First, what you have to do, Fisher projection if they have given, try to convert into the eclipsed conformer. Try to convert into the which one? Eclipse. The SARS projection, convert it into the eclipsed. Here it is a H and here it is a Cl. After converted into the eclipsed, then you are converted into the Newman projection. You convert this into the Newman projection. In the Newman projection, hydrogen and the which one? Hydrogen and the chlorine should be, this is the back carbon. Now here it is a CH3, here it is a Cl, here it is a H. Then you fix the front carbon and rotate the back carbon, then make it into the which one? To the 180 degree. Not 180 degree, you just rotate it to the 60 degrees, so that here the CH, here the Cl, here the CH3, here it is a hydrogen. Now both are trans to each other, right? Both are trans to each other. After the making the trans to each other, you just eliminate and you will get the trans alkene in this manner. CHP, here the CH3, double bond. Clear? Now here the carbon CH3. Now here it is a H. Here it is a H. Clear? In this manner you will get the product. In this manner you will get the product. Done. Now by this I was ending the class. I hope whatever the doubts and whatever the misconceptions you are having, that it has been cleared, I think so. Now it's almost already it is a 10:10, so I was ending the class. Tomorrow in the next class what we'll do, we'll start with the questions and then followed by the lectures. SN1, SN2, E1, E2, E1, CB, combiningly we'll mix questions. We'll start with the questions and and followed by the lectures. Okay, ambident nucleophiles as well as ARSN, aromatic nucleophilic substitution. Okay. Mesomeric. Oh, you are there, right? Sorry, Ansh. Okay, remaining the ones who want to be in the live, the one who are in the live, if they want to listen the mesomeric effect, they can listen. If not, they can leave. Okay. For the Ansh, I will explain mesomeric effect. Okay, good. If anyone want to, you can leave. Pranit, you can leave. No problem. If anyone want to listen the mesomeric effect, they can be in this class. The remaining they can leave. Right. Now, what is the meaning of the mesomeric effect? Means mesomeric effect. Mesomeric effect means first displacement of pi electrons. Displacement of the pi electrons is known as a mesomeric effect. Clear? Here, how the mesomeric effect will be happened and where we can see. Where we can see the mesomeric effect. Here, mesomeric effect we can see only in the carbocation, or all should be intramolecular Woods reaction. Means, let's suppose here like this it is there, like this if it is having, then it will show the intramolecular, which one? Intramolecular Woods reaction within the molecule. Within the molecule reaction if it is happening, that we call it as a intramolecular SN reaction, sorry, Woods reaction. Is it clear? Here sodium and the dry ether if they have given, within the molecule it has happened. So this is a intramolecular SN, sorry, intramolecular Woods reaction. Is it clear? Now, right. Done. Right. This only product. This is only the product. This is only the product. Now, Ansh, can I start the mesomeric effect class for you at 10:40? Can I start 10:40? Because I was getting the dinner time, because it is almost the 10:15, right? Can I start you class exactly mesomeric effect at 10:45? Can I start, Ansh? Is it okay for you, or should I explain? Should I explain elaborately, or Ansh, should I explain mesomeric effect elaborately, or on the, like, if you are having any idea of the mesomeric effect, means I will explain normally. If not, sir, I don't have any basic of the mesomeric effect, means elaborately I will explain. I mean, you are having any listen, no problem. Okay, fine. You are waiting for the mesomeric effect, right? So I will clear for you the mesomeric effect so that you will also be happy. Right. See. CCl4, CH2Cl4, Cl. That only it will give. That it will give. It's okay. 1040. No problem. No problem. I will continue. I will continue. Unchance I will continue. No problem. Be in a line. I will continue. I will continue the mesomeric effect. Okay. Mesomeric effect I will continue, so that it will be clear for you also. Okay. By the 10:40 I will close the class. Really, just I need the one success, that's it. If you are happy with my lectures, that is very much enough for me. So whatever the hard work I was doing, that it is only to give you the happiness. The only, if you are following my lectures and if you are feeling happy, that it is enough for me. Okay. Now, what is the meaning of the mesomeric effect? Means mesomeric effect means, Darshan, is it clear for you? If it is given the CH2, 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 CH2 and Cl if they have given, now here the radical will form, this radical and this radical will form the bond in this manner. Then it will give the cyclobutane. Darshan, it will give the cyclobutane for you. Is it clear? Ansh, are you there? Ansh, are you there? I am continuing the mesomeric effect class for you. Ansh, are you there? Yes, sir. Done. Right. Listen. Now, what is the meaning of the mesomeric effect means? Now, mesomeric effect, resonance effect and the conjugation effect is same. Now, displacement of the pi electrons is known as a mesomeric effect. Now, sp3 carbon atom does not involve in mesomeric effect. Does not involve in mesomeric effect because due to the absence of vacant orbital. Done. Here, next, delocalization. What is the meaning of the delocalization? Means displacement of the pi electron. Delocalization to happen, all the atoms should be in the plane. Is it clear? It should be in the plane. Now, here also mesomeric effect to happen. Here also we are having the two types of the groups. One is plus M group, one is minus M groups. Plus M groups are electron releasing. Minus M groups are electron withdrawing. Okay. Now the which groups are the minus M or plus M? Plus M groups are lone pair containing groups. Lone pair containing groups, if it is attached to the sp2 carbon, those we call it as a plus M. Now these groups are the plus M groups. Arc. Now this is the halogens. Clear? Etc. These are the plus M groups. Minus M groups are all the carbonyl carbons. Cyanide, NO2, okay, CX3, now NH3, etc. These are the groups of the which one? Minus M groups. Done. Is it clear? Now we'll see how the mesomeric effect or resonance will be happened or delocalization will be happened. Types of types of resonance. What are the types of the resonance we are having? First one, pi-pi resonance or pi-pi conjugation. Second one, pi cation conjugation. Third one, pi anion conjugation. Okay, fourth one, pi free radical conjugation. Done. And the fifth one, pi lone pair conjugation. And the sixth one, cation lone pair conjugation. And the seventh one, pi and the vacant d orbital. Vacant d orbital. These are the some conjugations we are having. Now we'll see the first one, how the pi-pi conjugation will be happened. First one is a pi-pi conjugation. Now what is the meaning of the pi-pi conjugation? Pi-pi conjugation, see what I explained. Now delocalization to happen, all the atoms should be in plane or sp2. Clear? Done. Now in the pi-pi conjugation, if I take the 1,3 butadiene, 1,3 butadiene if I take, see all the carbons are sp2, right? Here the sp2, this is sp2, this is sp2, this is sp2. All the carbons are sp2. How it will be there? Now the pi bond will be formed by the which one? Now the sideways overlapping. Now due to the sideways overlapping, now this pi bond will be formed in this manner. Clear? Done. Ansh, is it clear? Then this pi bonds are parallel to each other. Next very key point you have to remember. Next very key point, delocalization to happen. Pi bonds and lone pairs are parallel to each other. Are which one? Parallel to each other. It should be the parallel to each other. Is it clear? They should not be the perpendicular. If they are the perpendicular, then there is no any mesomeric effect will be happen. Next. Here how the delocalization will be happen in the 1,2 butadiene means first this pi bond will be shifted here and this pi bond will be shifted here. Due to that what it will happen? Here it will get the negative charge and it will get the positive charge. Now this is the pi-pi conjugation. In this manner the pi-pi conjugation will be happen. Done. Next one. Second one. Pi cation conjugation. Now this one and here it is a cation. Sir, how come the pi cation conjugation will be happen, sir, if they ask? Because this carbon is sp2. sp2 one vacant orbital will be there in this manner. Now here in this manner, now whatever the pi bond we are having, this pi bond and this vacant orbital, this carbon vacant orbital, both are parallel to each other. That's the reason only delocalization is happening. This carbon is sp2, this carbon is sp2, this carbon is sp2, and this pi bond will be delocalized in this manner. When this pi bond has been delocalized in this manner, now here in this manner the which one? Pi and the cation delocalization will be happen. Now next, benzyl carbocation. If you cross check in the benzyl carbocation, now in this benzyl carbocation also, this carbocation which it is there, this pi bonds which are there, this pi bonds and this carbocation vacant p orbital, these two are parallel to each other. So that's the reason only for the benzene, if any lone pair containing species, if it is attached, it will show the which one? It will show the which effect? It will show the mesomeric effect or plus m effect only. Now listen. Ansh, are you there? Clear? Ansh, are you there? Is it clear? Now listen. Ansh, listen. Now if any lone pair containing species, if it is attached, if any lone pair containing species, if it is attached, then how it will show the plus M? Now we'll see. Wait. Here you can see this is a benzene, right? This is a benzene. Now this is a NH2. This is a NH2. This is a nitrogen lone pair. Now these pi bonds are formed by the pure p orbitals and they are formed by the sideways overlapping. Now here what I said, delocalization to happen, lone pair and this pi bond should be the parallel to each other. You may get to doubt that this lone pair and the pi bond is what? Perpendicular to each other, but not they are perpendicular to each other. Now you see, actually this pi bonds, due to the sideways overlapping, it will form the bond. Now in this manner you can see, now you will get have some idea. In this manner you can see, now this nitrogen lone pair of electron and this pi bond, this pi bond, both are parallel to each other, right? That's the reason only if any lone pair containing species, if it is attached to the benzene, they will show the delocalization effect, they will show the mesomeric effect to the benzene. Is it clear? All right. Yes, okay, right. Now, next, if suppose they have given in this manner CH2 double bond CH bond NH plus 3 if they have given, and CH2 CH and BH2 if they have given. Okay. Now among the 1 and 2, in which case delocalization will be happened? In both the cases delocalization will be happened. Ansh, now you see me, in both 1 and 2 the delocalization will be happened, or only in the case of 1 it will happen, or only in the case of 2 it will happen, or in the both the cases it will not happen, delocalization. What is the first criteria to show the delocalization? To show the delocalization, first criteria is to be all are sp2 and all should be in the same plane. And try to say me the answer. Try to say me the answer. Sir, in the first it will happen. No, in the first it will not happen. First this is a sp3 carbon. This is a sp3 nitrogen. Here the 3 hydrogens and 1 sigma bond is there. This is sp3. This sp3, this pi bond delocalization will not be happen. What I said, if any sp3 if it is present, delocalization will not be happen. This nitrogen being the presence of sp3 hybridized, here the delocalization will not be happen. Okay. Now here this is a boron. This is sp2. This is the sp2. Here the delocalization will be happen. In the 1 it will not happen. In the 2 it will be happen. It will be happen. Is it clear? Is it clear, Ansh? Ansh, one thing you do, Nana. This is the mesomeric effect. Actually, this is the concept of the mesomeric effect. Now, Ansh, what you do? Already in our playlist, I did the GOC lecture number 3 on the mesomeric effect with the molecular models. In that lecture number 3 with the molecular models, I explained with the molecular models very clearly over there. So what you do, once you see that lecture, once you see that lecture, almost in the 1 hour 10 minutes I was explained that lecture. If you have not cleared with that lecture, in the live, once in the live you ask me, there I will explain. Okay. Still if you are having the confusion, there I explained very clearly with the molecular models. I clearly. Okay, still if you are confusion, I will explain in the next live class, because it is almost 10:30 I was feeling so hungry. So don't mind. Okay, don't mind. Actually, I was feeling so hungry. Okay, Ansh. Okay, see you tomorrow in the next live session. Okay, okay, fine, fine. Ansh, where are you from? Ansh, where are you from? Where are you from? Okay, good, good. Everything. If you are facing any very problem in the chemistry, you can try to contact me. You are preparing for JEE or NEET? Ansh, you are preparing for JEE or NEET? You are preparing for JEE or NEET? JEE, okay, fine. My dear Ansh, if you are facing any problem in the chemistry, actually this is a live session. I cannot provide my personal mobile number for you. Already in the contact us, I was given my personal mail ID. Here also I will provide my personal mail ID. Once you text me, hi, I will provide my personal phone number for you, so that whatever the doubts you are having, you can personally you can send it to me. I will clear it for you and I will send it to you. And whatever the notes and whatever the any textbooks or any question banks, any practice models, if you need, I will give you or I will send you to over there, because this is my personal mail ID. You can text me, sir, I am the Ansh, so and so, so that I will respond over there and I will send it to you, and I will give you my mobile number over there. Okay. And if you are following the lectures daily, I can help you and I will make you the whatever the misconceptions you are having for your in our entire chemistry. Okay, fine. Good night. Good night, and see you tomorrow. Good night. See you tomorrow. I was ending the live. Okay, fine, fine, fine. Fine.